Hello students, welcome once again into the Swayam online lecture series on AI using Prolog. In today's lecture, we will be talking about natural language processing. Now, what is natural language processing? Whenever we make a computer system understand the natural language means the one which we speak like English, Hindi, French, German, etc. So, what are techniques or what are methods which are used by the computer system to understand a language? Now, there are various applications of NLP like language translations or speech to text conversion, text to speech conversion, so on and so forth. In this lecture, we will basically study what is NLP, what are different phases of NLP, what do we mean by grammar and the language, what are parsers, what is syntactic parsing, and two fundamental parsing techniques which are conventionally very popular, recursive transition network and augmented transition network. So, let us start by understanding what is natural language processing. As said earlier, natural language is the language which we speak like Hindi, English. We want our computer system, we want to develop system which can understand this language. So, we as a humans have an intelligent behavior and we are able to perceive and communicate the important components. Developing programs that understand the natural language and comprehend the visual scenes are two most difficult tasks in the field of artificial intelligence. Entire language processing problems are divided into two parts, either the language is spoken or the language is written. So, we want our computer system to understand a spoken language or the written language. Generally, in today's lecture, we will more focus on the written text. So, natural language processing is basically the set of programs which understands the language, and after understanding a language, it is able to take certain correct action in response to the given input. In this lecture, we will focus basically on the written text. So, to understand the language, program must have the complete knowledge about that language, the structure of that language, the grammar, the phrases, and also the system must understand or interpret the sentences correctly. So, there are various different phases of NLP, 7 different phases starting from the beginning: the phonological analysis, morphological analysis, syntactic analysis, semantic analysis, discourse analysis and pragmatic analysis. Let us take each of these phases one by one. The phonological analysis deals with the speech. Whenever we talk, the sound which is generated needs to be converted into the text. So, understanding of the sound signal is basically the phonological analysis. Once we have the text, now we want system to understand the text. So, the next level, morphological analysis, basically converts the sentences into the words. Then each word is basically divided into prefix, the root word and the suffix. Prefix and suffix may or may not exist, but if they do exist, the morphological analysis will try to find out the root word by removing the prefix and the suffix. As given in the example, friendly, the root word is friend, suffix is ly. So, morphological analysis will do this kind of an operation to pick up a root word. Then comes the syntactic knowledge or the syntactic information which is required to build the system. Whenever the sentences are given, it is very essential for the NLP to understand the syntactic structure or the grammatical structure of the sentence. So, the software must have the knowledge related to how the words can be joined together grammatically, so that the entire sentence is correct. Generally, the parsers are used to perform this task. Above syntactic representation is the semantic analysis. When we talk about the semantic analysis, we have done the morphological analysis, we have understood the structure. The next level is what is the meaning of the sentence. So, whenever we process the meaning, the semantic analysis is done on the sentences. They use generally the syntactic structure to construct a semantic structure. So, what do? They actually take the individual word and try to identify how context wise they are related to the other words in the sentence. Another more complex NLP task is discourse integration. It basically talks about how to replace a pronoun with a noun. Let us take an example. John wanted it. When this sentence is given, it is a pronoun. So, it should be replaced with which noun? This is a very context based problem, and the system must resolve this problem. It must replace it with the correct noun, and this problem in NLP is known as co-reference resolution. So, this level of task is dealt in discourse integration. Above discourse integration is pragmatic analysis. We know that natural language is full of ambiguities. It is full of sarcasm. So, how to detect these sarcasm? They are dealt in the higher level pragmatic analysis. Let us take an example. For example, a teacher asks, "Do you know what time it is?" to a student who is entering the class. It means the teacher is not asking the time, but it is basically trying to make student that you are late in the class. So, these are the basic 7 phases of NLP. In this lecture, we will more focus on the syntactic level or parsing of a sentence and what are different parsers. So, what do we do in the parsing or syntactic parsing? At input level, a sentence is given to the system, and the work of a parser is to develop or to generate a syntactic structure of the sentence, which reveals the grammar. So, most of the syntactic structures, they have 2 important components. One is the grammar which is needed, and the other is parser which is needed. A grammar of the language and a procedure which is known as a parser, which will compare the grammar against the input sentence to produce a parsed structure. So, what are grammar in the language? In a very raw form or in a very raw level, we all know the grammar and the language. But when it is presented in a formal form or in a mathematical form, then the grammar is defined by 4 tuples as given: Vn, Vt, S and the P. Any language having a grammar will have these 4 components, which are nothing but set of non-terminal, the set of terminal, the starting symbol and set of production rules. Let us understand this with the help of example. As we can see, the non-terminal consists of the variables the start S, NP which stands for noun phrase, N stands for noun, VP stands for verb phrase, V is the verb, art is the article. Terminal values are boy, ate, apple, flew, a, and P which we can see on the slide are the production rules of a language. Let us take a very first sentence. S generally in English is made up of a noun phrase and a verb phrase. This is one of the production rules. Likewise, there are production rules for the noun phrase, verb phrase, noun, verb. Using this grammar, we can generate a sentences like a boy ate an apple, which is grammatically correct. We can also generate a sentence, an apple ate the boy, which is syntactically right, but semantically incorrect. Irrespective of theory of grammar, parsing process takes the rules of the grammar and compares them against the input sentence. Each matched rule adds to the structure being built for the sentence. The simplest structure, like we give an input sentence and any syntactic processor has to give an output structure. The most popular output structure which is generated by the parsers are the parse tree. Let us see how parse tree looks like. As given in the figure, the production rules which are stated on the left side states that a sentence is made up of a noun phrase and a verb phrase. So, in the corresponding parse tree, we bifurcate S into two nodes NP and VP. Again, noun phrase is made up of article and the noun. So, NP is again bifurcated into two nodes, article and the noun. Then article is having the value the, noun is having the value boy. So, this is the using the production rules given on the left hand side, a parse tree is being generated or created, and this parse tree can generate a sentence like the boy ate an apple. This parse tree is also known as phrase marker. Some of the additional structural representations are given over here, like we can have rules for the prepositional phrase, the adjectives, the determiners, the adverbs and auxiliary verbs, and production rules related to them are given in the slide. For example, the mean boy locked the dog in the house, and the remaining two example, all these sentences they follow the form ki sentence is made up of noun phrase, verb phrase followed by the prepositional phrase. If the complete production rules are given, we can construct a parse tree which will be an output of a parser. So, basic parsing technique consists of the input string, the parser and the lexicon. The parser takes the input sentence, which is a flat sentence. It uses the lexicon, which is a dictionary of the words, and using this lexicon, it generates an output structure of the type parse tree. There are various parsing techniques which are available. Some of them are like top down parser or bottom up parsers. If we start with the start symbol and we apply the production rules till we get a terminal node, this processing is known as top down parser, and if we start from the bottom and accumulate the terminals and come up with the rules, this is a bottom up parser. Let us see an example of top down parsing. Kathy jumped the horse. Using the production rules, starting with the symbol S, we start from S, which is a topmost value, and then later on each of these values are converted into terminals, and the final terminals are Kathy jumped the horse. This way of processing is top down parsing. The same sentence can also be processed in a bottom up manner. Kathy jumped the horse. We start from these terminals and we accumulate these words to generate the rules, and then we end with the starting symbol. This type of parsing is from bottom to up. Another parser which is very popularly used is known as transition network. It is basically a directed graph and it has its behavior similar to a finite state automata. It has nodes and it has labeled arcs. Node represents the different states while traversing a sentence. Arc represents the rules or the test conditions that should be applied on a word or on a phrase for moving from one state to another. So, let us see what are transition networks. A path or a complete route in a transition network is nothing but permissible or permitted sequence of words for a given grammar. If a sentence traverses the entire network successfully, it means that sentence is correctly built on the given grammar. If the sentence does not pass that network, that means the grammar of that sentence is incorrect. Let us see the example of transition network. As we can see, the above figure having where the nodes are N1, N2, N3, the tests are determiner, noun and the verb. And in the below diagram, it is a more generalized network where we can see there are multiple arcs from N1 to N2, and there is a loop of adjective in the N2, because whenever we refer a noun in a sentence, it can have more than one adjective. So, what are the sentences which are processed by the second diagram? The big white fluffy clouds. From N1 it passes the adjective test, moves to N2 because big is an adjective, next white is an adjective, so loop in N2, fluffy is an adjective, so loop in N2, and then clouds is a noun to N3. So, this is the way how these sentences are processed by the second diagram. All the examples which are given over here will be syntactically correct under the given transition network. So, as we see the big white fluffy clouds, our bright children, a large beautiful white flowers, all these are the valid sentences that can be traversed through the given transition network. There are two very important type of transition network. One is a recursive transition network and the other is augmented transition network. Recursive transition network is very simple, more powerful, and it only gives whether the sentence have a correct syntactic structure or not. Additional information on this network was built using an augmented transition network. Recursive transition network only gives whether the sentence have a correct syntactic structure or not, whereas the augmented transition network is more powerful. It requires storage, but it also gives a structure as an output which is helpful in the semantic analysis. So, let us look into these networks one by one. So, recursive transition network is a recursive network because here the arc labels, they refer to not only a particular category test, but it is also at times is a call to another network, like we perform in programming a call to a function or a procedure. Labels which are referring to other networks are generally written in upper cases. Let us see in the diagram which is given in the slide. This network was given by William Woods, and as we can see in the first network, we have S1 as a node and NP as a call to another network NP. So, S we start from S1, there is a call to noun phrase NP. So, we go to the noun phrase network, that is N1. From there we have determiner, adjective, noun, and again a prepositional phrase. So, call will move to another network which is a prepositional phrase. This is the way the recursive transition network works. We have got a main transition network S, and in that S two sub transition noun phrase and prepositional phrase are recursively used. So, what type of sentence will be processed using this recursive transition network? Let us take an example and see. The big tree shades the small house by the river. Big tree is a noun phrase. Whenever this sentence goes through the main transition network S, it starts from S1. The big tree is a noun phrase, so it will go to the NP network. After successfully coming from there, it will end in S2. Shades is a verb, so it will pass that test verb and move to S5. In S5 again the small river is a noun phrase, so it will go to S6. By the river is a prepositional phrase, so call to a preposition network will be there, and this will be the end of the sentence, meaning this particular sentence successfully passes the entire network, meaning that it has a correct syntactic structure. Now, this RTN uses various data structures. 3 data structures which is used to process the sentence are the position of the current input word position, POS, the current node, the stack, and the RTN parser will terminate whenever the main transition network pop is encountered. RTN has certain drawbacks. It has only an output, either it will accept or it will reject a sentence. There is no definite structure is provided for further analysis. If I want to perform a semantic analysis over an output of an RTN, that cannot be done, because output of an RTN is only whether the sentence is syntactically correct or not. It has some plus point also. It is very simple and there is no memory required, no overhead required. Because of these drawbacks, the people or the researchers, they added some additional stuff to the recursive transition network to create an augmented or advanced transition network. So, recursive transition network was added with additional features, hence the name augmented transition network. The number of sentences which can be accepted by the transition network can be extended if we are allowed to perform multiple tests, backtrack, come back to a point and then start tracing the sentence. Parser must have the capability to build the structure. Output which is obtained from the transition network must give some structure to analyze and perform semantic analysis. The resulting data structure must contain more information. It should be more informative so that we can perform further analysis. Semantic should also be a part of it. For this additional information, we used, or the augmented transition network used the subject, NP, object, subject verb number arguments, the mood, the type of the sentence, declarative or interrogative, what is the tense of the sentence, what is the location, etc. So, these additional information were added. To include more semantic information into the structure, using these registers, ATN builds a partial description of the sentence as it moves from one state to another. These registers provide a temporary storage which can be modified, erased or discarded. For example, if we are parsing a sentence onto this network and some of the test fails, then there is a possibility to traverse back and erase the content of the register. And then from the backward point, we can follow another path. So, the new set of registers will be set with the new values, and the values of all these registers will be then combined, accumulated to generate an output structure. So, after successful parsing, the contents of the registers are combined for final sentence structure. For ATM to work properly or accordingly, a ATN specification language was needed. This was given by Woods and it is extended form of context free grammar. Using the specification language, we can represent a particular ATN network with the constituent abbreviations and the functions which are generally described in a Lisp program. Lisp is basically a language used to develop the artificial intelligence program. Some of the characters or symbols are shown in the figure, like while how to input a word, how to use the non-terminals, how to repeat the zeros and so on. So, whenever in the network, in the ATN network, the ATN specification uses symbols on the R-car, category test, cat, jump, that means simply to ignore that arc, push, that means it is a call to the another network, test, which means there is a category test on the arc, or pop, that means coming out of the network. Action in the form of functions. Some of the actions which are used in the ATN specification language is set R. What set R does? It is a command and it causes or it indicates that register should be set to a given value. There are various types of registers. Send R causes it to be done by sending to the lower level. Get R returns the value of the indicated register. These are some of the commands which are used by the ATN language for setting up the register, for erasing the value, for building the entire structure. Example, build queue command will build the entire structure. It will take the data from all the registers and build a structure. Jump requires simply to move to the next node. So, the similar diagram which we had seen in the RTN is now shown with the ATN specification command. As we can see in the S1 or in the main network S, where S1 had an arc NP, now it uses push NP. Whenever a push command is there, that means there is a call to another network. Then the next arc has cat V, which means the category, this arc will test the category verb on the word. The next push NP means that arc will actually call another network noun phrase. So, we see there are different types of nomenclature which are used in the ATN specification language. So, this is an ATN network. Let us see an example of ATN specification language for this particular network. On the left side of the figure, we see the same diagram, and on the right side is the ATN specification language. Let us see in the line number 1. As we say the starting network S, there are two possibilities. One is push NP and the other is a category auxiliary test. So, if the word follows the first part, then the registers will be set to subject register will be set because it is a noun phrase. The sentence type will be declarative because whenever the sentence starts with the noun phrase like the cute little girl, then this type of sentence is a declarative sentence. So, if the sentence follows S push NP is true, then the register subject will be set on the input value and the register type will be set to declarative, and then the system will move to the next node, which is S2. If the second arc auxiliary test is true, then the register auxiliary will be set to that register. For example, can I have your pencil? So, can is an auxiliary word. So, can will be stored in the auxiliary register, and in that case the type register will be set to a question mark, and then it will move to the next node. From S1, again if the category verb is true, then the verb or the auxiliary register is set to nil, but the verb register will be set to the input value. So, these actions are defined on the right side using the ATN specification language. So, what we see in the slide here, left side is the entire ATN, right side is the language which is being used to take the input and set the different registers. Once the entire sentence has been processed, this ATN will return a structure. Below is an example, the big boy likes the small dog. If this sentence is passed through this network, it will give an output which is given over here, like the type of the sentence is declarative, then the noun phrase consists of boy, which is defined by big, and it is a definite, that is the big boy. Verb phrase values will be stored in the verb registers, and these registers will return a structure which is defined over here. So, here we see the output of ATN is a structure, whereas output of RTN was simply a yes no type of an answer. Another examples, another sentences which can pass this transition network, ATN transition network, is the boy can whistle. This will follow a different path, and the structure return is that it is a declarative, the noun phrase will consist of boy, and it is a determiner, auxiliary verb can, and verb phrase whistle. So, this structure is returned by the augmented transition network. So, what are the advantages of augmented transition network? Augmented transition network, it not only makes use of ARC in the test, but it helps us in giving a output structure based on which the semantic analysis can be done. However, it also has a drawback, like additional registers, additional storage or overhead is encountered while processing an ATN. Time taken to process an ATN is more as compared to the RTN. Why? Because the registers needs to be manipulated. If the values are not correct, we backtrack, then registers are erased, and again new set of registers are set to the different values. Whenever we want an output, a build queue command has to read the values from the registers and then construct a particular structure. So, disadvantage is overhead is required, backtracking will take more time, and overall processing is little bit complex. So, out of RTN and ATN, RTN is simpler in nature, but it gives the only output ki whether syntactic structure is correct or not, whereas augmented transition network, it gives a structure of the sentence for further analysis, but at the same time on the cost of an overhead or an additional time which is used to which is taken to process the registers or the words. So, in this lecture we talked about the very fundamental aspects of natural language processing. What are its different 7 phases, what are parsers, what is a parse tree and how to construct a parse tree, what are top down and bottom up approaches, a recursive transition network, augmented transition network, its benefits and its disadvantages. NLP is a very common field in artificial intelligence nowadays, and here the input sentences nowadays, the input sentences are now being converted into vectors or numbers, and machine learning algorithms are developed to process this input. Whenever a text is given to a machine learning model, it is not possible to process these words or the text directly, because a model understands the values. So, what was required was to convert the text or the input sentences into the numerical values. The various techniques over the past few years have evolved, which converts these words or sentences into the numeric form. Few of these techniques are one-hot encoding, word-to-vec or word embeddings. These are popularly used to convert the text into the values. Once the text or the words are converted into the numerical form, the machine learning algorithm can be applied. And nowadays, NLP is becoming very much popular, and machine learning models are being implemented to solve various real-time applications. Like in Gmail, we find the prediction of the sentences is done. In text messaging, again the prediction of sentences are being done. In order to find the sentiment of a review which is written by a customer, again an NLP along with the machine learning model is implemented. What reviews are given by the users? There are various applications of NLP, and I know this one lecture is not sufficient enough to cover up all the topics. I hope in this lecture you understood the fundamentals of NLP and the working of the fundamental parsers like recursive and augmented transition network. Thank you once again.